Imagine this, our entire galaxy, the Milky Way, drifting through the vast darkness of space. Not randomly, not aimlessly, but being pulled, as if something unseen, something massive is dragging it across the cosmic ocean. This isn't science fiction. This is real, and astronomers call it the Great Attractor. It sounds like the name of a myth, something from a cosmic legend. But this Great Attractor is not a black hole we can see, not a star cluster glowing in the night. It's invisible, hidden behind a dense wall of dust, stars, and galaxies that obscure our view. So, what is it? What is pulling our galaxy, and billions of others, toward a mysterious point in space? To understand this mystery, we must first look at the grand map of the universe, the cosmic web. Imagine threads of galaxies, stretching across space like a three-dimensional spider web. Each node in that web is a galaxy cluster, enormous cities of stars, gas, and dark matter, bound together by gravity. Now, within this cosmic web, everything moves. Nothing is standing still. Galaxies drift, twist, and fall toward greater concentrations of mass. Our own Milky Way belongs to a small group of galaxies called the local group, which itself is part of a much larger region, the Shapley Supercluster. And at the center of this vast region lies something powerful, something that bends the path of galaxies themselves. That is the Great Attractor. When astronomers first discovered it in the 1970s and 80s, they didn't see it directly. They felt its presence, through motion. Galaxies weren't where they should have been. Their speeds didn't match what the expansion of the universe predicted. Something invisible was tugging on them, drawing them toward one direction in the sky. That direction was toward the constellation Centaurus. But when telescopes turned to look, they found nothing. No giant cluster of stars, no bright nebula, just darkness. The mystery deepened. Scientists began calling that hidden zone the zone of avoidance because dust and gas from our own Milky Way block most of the light from beyond it. And somewhere in that darkness lies the Great Attractor. For decades, astronomers used radio telescopes, all converging toward a single gravitational center. But here's where things become truly strange. Even though the Great Attractor seems to pull everything nearby toward it, the entire structure itself is also moving. Yes, the Great Attractor isn't stationary. It's being dragged by something even larger, an even more mysterious region known as the Shapley Supercluster. It's as if space itself is flowing, a cosmic river, and we're just passengers, carried downstream by an invisible current. Now imagine this for a moment, our entire galaxy, our sun, our solar system, and even the light we see from distant stars, all drifting together through the void, towards something we cannot see. What could it be? A massive cluster of galaxies, a concentration of dark matter, or something beyond our understanding, a hint of new physics. The truth may lie in how we see the universe itself. In the early days, scientists thought gravity was the only force shaping the cosmos. But then came the discovery of dark matter, the invisible glue that binds galaxies. And later, dark energy, the mysterious pressure driving the universe apart. Now we stand between these two extremes, a force that pushes everything outward, and another that pulls everything inward. The Great Attractor sits right at the heart of this balance, a gravitational anomaly that defies simple explanation. If we could see it clearly, what would it look like? Maybe a vast cluster of galaxies, their combined mass bending spacetime like a colossal dent in the cosmic fabric. Or maybe it's not a single thing at all, but a region where gravity and motion converge, shaped by thousands of unseen structures connected through dark matter filaments. Whatever it is, it's powerful enough to influence motion across hundreds of millions of light years. To visualize this, imagine a map of the universe, galaxies scattered like glitter, across a black background. Now, draw arrows showing their motion. You'll see a stunning pattern. Nearly every arrow points toward one region, a massive gravitational basin. That basin is where the Great Attractor lives. But here's where the mystery deepens even more. Some data suggests that the Great Attractor isn't just made of visible matter, but mostly dark matter. In fact, up to 90% of its mass could be invisible. We can't see it, we can't touch it, but we can measure its pull. It's like standing in the ocean and feeling the waves beneath your feet, even though you can't see what's causing them. That's what the Great Attractor is, a ripple in the cosmic ocean, felt by every galaxy near it. And we are drifting straight toward it. But don't worry, we won't ever reach it. Not in billions of years. Because while gravity pulls us in, the expansion of the universe is also pushing everything apart. It's a tug of war between two unimaginable forces, and we're caught in the middle. As our understanding deepens, so does the mystery. The more we learn about the Great Attractor, the less we seem to understand. Scientists now know that this region, this hidden gravitational well, is not a single object, but a complex network of galaxy clusters, filaments, and dark matter all intertwined. Among them lies one of the most massive structures ever discovered, the Norma Cluster. Buried deep in the zone of avoidance, the Norma Cluster is a colossal gathering of galaxies, perhaps the beating heart of the Great Attractor itself. Its gravity is so immense that even light bends slightly as it passes nearby. When astronomers mapped the velocities of thousands of galaxies across the sky, they noticed a curious trend. All motion seemed to converge near Norma. And yet, it wasn't enough. The observed pull could not explain the full motion of our Milky Way and its neighbors. That's when something even more astonishing was found far beyond the Great Attractor. About 650 million light-years away, another massive structure, the Shapley Supercluster. It's one of the largest known concentrations of galaxies in the observable universe, thousands upon thousands of them, all bound together in a gravitational dance. And it's even heavier than the Great Attractor. For decades, astronomers thought the Great Attractor was the final destination, the anchor of our cosmic motion. But now, it appears we're not just moving toward the Great Attractor. We're being drawn past it, toward the far greater mass of the Shapley Supercluster. Imagine a cosmic landscape, vast valleys and hills made of gravity itself. Our galaxy, the Milky Way, slides down one of those invisible slopes, pulled first by the Great Attractor, and then by the towering mountain of mass beyond, Shapley. We're not falling toward a single object. We're flowing along a gravitational river through the cosmic web. And yet, we can't see most of what's driving this motion. More than 95% of the universe is dark energy, dark matter, both invisible, both untouchable. It's strange to think that our entire galaxy's fate is shaped by something we can't even detect directly. In a way, the Great Attractor is not just an astronomical mystery, it's a philosophical one. It forces us to ask, what else is out there, beyond what our eyes can see? What if our understanding of gravity, of space, of the universe itself, is incomplete? Some scientists even suggest that the Great Attractor might not be a thing at all, but a region of space-time warped by something deeper, perhaps a massive concentration of dark matter, perhaps a curvature in the very fabric of the universe, or, some have speculated, a gateway, not in the science fiction sense, but a region that bends the large-scale structure of reality itself. It sounds fantastical, but so did the idea of black holes once. So did dark energy. Every great mystery begins as the impossible. To visualize the scale of this motion, think about this. Our galaxy, the Milky Way, is moving toward the Great Attractor at over 600 kilometers per second. That's 2.1 million kilometers every hour. And even at that unimaginable speed, it would still take us over 150 million years just to get halfway there. Now picture billions of other galaxies, all moving too, all being pulled by gravity from countless directions. It's like watching the ocean. Billions of waves moving in patterns we barely understand. And somewhere in those waves is us. Our home. Our fragile blue planet. Every sunrise. Every life. The Great Attractor reminds us of one simple truth. We are not the center of the universe. We're part of something vast, ancient, and still unfolding. A cosmic current that began long before we existed and will continue long after we're gone. But maybe that's what makes it beautiful. Because even though we may be small, our curiosity, our need to understand, is enormous. We build telescopes that peer through dust and time. We measure faint ripples in light from galaxies millions of light years away. We map the invisible not because it affects our daily lives, but because it defines our place in the cosmos. Every discovery we make brings us closer, not to the Great Attractor itself, but to understanding what it means to exist in a universe of infinite mystery. And perhaps one day, far in the future, when technology has advanced beyond imagination, our descendants will finally see it clearly. They'll peer through the dust, past the zone of avoidance, and witness the true face of the Great Attractor, not as an invisible force, but as a grand structure of galaxies, light and shadow, the very heart of our cosmic journey. Until then, we drift, our galaxy, our stars, our world, carried silently through the darkness, toward an unseen destination. Maybe the Great Attractor is not just a region in space. Maybe it's a reminder that no matter how small we are, we're all connected by invisible threads, pulled together by the gravity of the unknown. Voice softens to a whisper. The universe doesn't need us to understand it, but we need to try. The Great Attractor, the invisible force pulling our galaxy, is not just a mystery of science. It's a mirror, reflecting our endless desire to explore, to question, and to find meaning in the dark. Because in the end, it's not about where the universe is taking us. It's about the journey we take to understand why.